Hi there, I'm going to do 5 example problems that are very similar to the homework that I assigned you, and they all have to do with similar figures and the ratio of their perimeters and the ratio of their areas. So when you went through and did your geometry homework over the weekend, you should have listened to the videos and or went through all of the slides that Miss Griffith or Mr. Decker gave you, and you found out the ratio of the perimeters of similar objects is just the ratio of their side lengths. So it could just be, one side to another corresponding side in the second figure, or the height of a figure to the corresponding height of a second figure. So the book calls this a perimeter ratio. I like to just call it a distance ratio because it's a side or a perimeter or some length to the corresponding length in the second figure. The second ratio that you guys learned about was the ratio of areas of similar figures. So that's this one right here. If you know your perimeter ratio, A to B, you just square A and you square B and you get the ratio of the areas of the two similar objects. So let's work these examples that are very close to the ones you have on your worksheet to complete. So the very first one says, find the area of the smaller trapezoid. So when we take a look, we have a side length for one figure. Whoops, and I erased it. We have the side length for one figure, and we have the side length for another figure, which is nice because when we're talking about side lengths, that is your perimeter ratio. So I'm going to set up a ratio of my perimeters or my side lengths, and that would be the small one to the big one would be 12 to 18. And let's call it A to B. Like in the formula, A to B, and A is going to be 12 and B is going to be 18. The nice thing about ratios is that you can reduce them, and both numbers 12 and 18 have a common factor of 6, so we're going to reduce them by a factor of 6 to get a perimeter ratio or an A to B ratio of 2 to 3. So how do we get the ratio of areas if we have perimeter? Well, if you take a look above, the ratio of areas is just our perimeter ratios squared. So our area ratios, our A squared to B squared, is just going to be 4 to 9. And that gives us a nice ratio of 4 to 9, small to big ratio that now we can use to set up a proportion to find the area. So the small trapezoid, we don't know the area, so we'll put it in X for the small because we did do small over big. So small for X, the area of the big trapezoid is 121. So when we cross multiply, we get 484 equals 9x. And when we divide both sides by 9, we get x equals 484 ninths centimeters, or meters squared. Because remember, area is a squared dimension. So let's move on to the next example. It says a rectangular lot of land costs $24,000. Well, the cost of land is based on the area of that land. So in order to find the cost of land, we're going to have to set up an area ratio. It says another similar lot is 3 times as long and 3 times as wide, meaning the distances are 3 times the distances on the smaller lot. How much would you expect to pay for this lot? Well, let's go ahead and set up the area. Or we don't have the area. We're going to set up the perimeter or the distance ratio. Remember, distances do not have square dimensions. And that's how I know I need my distances. Well, I know in the smaller lot, it has, let's just call it A, the bigger lot has a side of B. How do they relate though? Well, I don't really know the size of the smaller lot, so I'm just going to call it A. But I do know the bigger lot has a length 3 times that of the smaller. So I could say 3A. And I can reduce this ratio by reducing out a factor of A. So I have a perimeter ratio of 1 to 3. So now we need to find our area ratio by squaring our perimeter ratio. So A squared to B squared will be 1 to 9. That gives us a ratio that we can use to set up a nice proportion to solve. Well, we know the smaller lot is $24,000. And we need to know how much the larger lot will cost. Well, let's go ahead and cross multiply. And we get $216,000 when we cross multiply. So X is $216,000, and that would be the cost of the larger lot. So now let's go ahead and do an example. And I have my formulas above. It says the area of a smaller, let's go ahead and erase my work here. I don't want you to see it. The area of a smaller rectangular or regular nonagon is 120 feet squared. That is a area ratio, obviously. It tells us that, but I also know its area because it has a dimension of feet squared. And then it goes on to say, if a larger nonagon has side lengths that are 5 times as long as a smaller nonagon, find its area. Well, again, I can't set up my area ratio because it's asking me for the area of the larger nonagon. So I'm going to have to set up my perimeter ratio. And what do we know about their perimeters, or distance at least, on the nonagons? I know if one nonagon has a length of A, the other one has a length of B. But in terms of really how long B is compared to A, if the smaller one is A, the larger one is 5 times that, so it's 5A. And when I reduce by a factor of A, I get a perimeter ratio of 1 to 5. So now I can set up my area ratio by squaring my perimeter ratio. So A squared to B squared is going to equal 1 to 25. So with that, I can set up a proportion using my area ratio. And I know the area of the smaller nonagon is 120 feet squared. And I do not know the area of the larger one. But when I cross multiply, I get X equals, let's see, 3,000. 3,000 what? It's going to be 3,000 feet squared. So that is the area of my larger nonagon. Okay, so on to our next one. It says find the value of X and Y when the smaller triangle has an area of 12 centimeters. Well, I think one of the things that we don't have is we don't have a distance, a side length on the smaller triangle. So I can't set up my perimeter ratio. And I don't know, or at least they haven't given me the area for one of my triangles. They gave me the area of 12 centimeters for my small triangle, but can I calculate the area of my larger triangle? I think I can, because the formula for area of my larger one is 1/2 base times height. And I know the base of that larger triangle is 12, and I know the height of that larger triangle is perpendicular to the base. There's my perpendicular symbol. That means 8 must be the height. And when I multiply that out, I get 48 centimeters squared. So now I have the area of the smaller triangle. I calculated the area of the bigger triangle. I can set up my area ratios. My area ratios are a squared to b squared. So my smaller triangle is 12 and my larger triangle is 48. This area ratio reduces by a factor of 12 and I get a ratio of 1 to 4. So if a squared is 1 and b squared is 4, I can easily find my perimeter or my distance ratio by unsquaring those numbers. So I can find that the square root of 1 is 1 and the square root of 4 is 2. And this gives me a nice ratio to solve for the distances of x and y. So let's go ahead and solve for x first. I have a perimeter ratio of 1 to 2, and I know that x is on the smaller triangle, and the corresponding side on the larger triangle is 8. And when I cross multiply, I get 8 equals 2x, and when I solve for x, I got x equals 4. Let me box that in. To solve for y, I'm going to do the same thing, but now I'm going to find the corresponding side to y on the bigger triangle. And when I cross multiply, I get 12 equals 2y. And when I divide by 2, I get y equals 6. Okay, last problem that we're going to go through. It says, compare the blue figure to the red figure. Find the ratio of their circumference and areas. So the wording of this is a little confusing because I would think that we would have a ratio of the blue to the red. But really what we're doing is we're comparing the blue to the red. So when we set up our ratios, we are going to set them up. Let me put that in a different color. We're going to set them up as the red figure to the blue figure. Okay, this way we're comparing the blue to the red. So let's go ahead and find the ratios of their circumference. Circumference is a distance. When we measure circumference, it's measured in inches or feet or miles. We're not squaring that dimension. So that's our distance or our perimeter ratio. So what do we know about the circumference or the perimeter or our distance ratio? Well, they did give us the radii of both of our circles. Our radii is also a distance, right? It's just the length of the radius, which is a distance. So let's go ahead and do the red circle first. The radius of the red circle is 2x, and the radius of the blue circle is 5x. And when I reduce by a factor of x, I get a circumference or perimeter or distance ratio of 2 to 5. So it's easy once we have our distance ratio or our perimeter ratio to find our area ratio, because our area ratio should just be a squared to b squared. And if a is 2 and b is 5, our area ratio is 4 to 25. And that's how you should be working all 5 problems on your homework assignment.